Hello students, I hope you all are doing well. Welcome to our math class of standard 8th. Today we are going to do one interesting topic. But before that, I want you all to watch a video carefully and think about it from a math point of view. So let's watch a video. Students, what did you all observe? Yes, many of you are thinking right. The video was based on a very well-known game, Candy Crush, that you all love to play, right? And in that video, we observed that same color candies multiply together and we get a bigger version of the candy. And then the bigger version gets expanded and expanded up to its limit. So students, today we will also learn how to expand a formula when we have three variables and learn more about expansion formula. Now students, in your previous class or standard, you all must have studied or learned a formula a plus b the whole square. So let's recall the formula. A plus b the whole square. So we all know we have square in the index place. So we write a plus b twice. That is 2 times, which is equal to a plus b multiply a plus b. Now, after that, what do? We multiply first brackets each term with the second brackets terms. So what do we get? We get a into a plus a into b plus b into a plus b into b. So we get a square plus ab plus ba plus b square. Now we all know ab plus ba is nothing but equal. So instead of writing ab plus ba, we write it as 2 times of ab, which is equal to a square plus 2ab plus b square. Now, as we saw how to derive formula for two variables, similarly, using the same method, we can derive expansion formula for three variables. But before that, we are going to derive expansion formula by using geometry. Now, here we have taken a square whose one side is equal to a plus b plus c, and you all can see that I have done the markings as well as a, b and c horizontally and vertically as well. And I've divided the whole square into 9 different parts. Now we have got this square whose one side is equal to a. So by using area of a square formula, which is equal to side square, we will get a square. Then we have one more square whose area or whose side is b. One side is equal to b, so its area will be b square. Similarly, we have one more square whose length is c, or one side is c, so we get it as c square. Now we have 6 rectangles, 1, 2, 3, 4, 5 and 6, right? So we have 6 rectangles, but these 6 rectangles we can divide it into two parts. Now, as this rectangle and this rectangle has similar dimension, whose length is equal to a and width is equal to b. So, by using area of rectangle formula, which is equal to length into breadth, we get a into b and a into b in this rectangle. After that, we have this rectangle and this rectangle similar, whose length is equal to c and whose breadth is equal to b. So we get the area as BC. And we have one more rectangle whose area is same, where the length is equal to a and breadth is equal to c. So we will get area of this rectangle as AC. So now, what can we say about the area of the bigger square? Area of the bigger square is equal to a plus b plus c, because we have one side of this bigger square as a plus b plus c. So as one side of the bigger square is equal to a plus b plus c, so by using area of a square formula, we will get a plus b plus c the whole square. So this can also be written as sum of the individual areas, that is equal to a square, area of this square, b square, area of this square, plus c square, area of this square, and plus area of the rectangles, which is AB, and this AB, which is going to be 2 times of AB. Similarly, 2 times of BC and plus 2 times of AC. So with this, we have derived formula for a plus b plus c the whole square using geometry. Now we will see the alternative method to derive the same formula. Now previously, as we derived the formula for a plus b the whole square, similarly we are going to derive the formula for a plus b plus c the whole square, and this method will be used to solve sums. So students, please pay attention. So a plus b plus c the whole square is equal to a plus b plus c multiplied by a plus b plus c. As we know, we have square in the index place, so we have written it twice, that is 2 times. Now, first bracket, first term gets multiplied with second bracket terms. Then second term gets multiplied with the second bracket And similarly, third term, that is C, also gets multiplied with the second term. And we get A multiplied by A plus B plus C plus B multiplied by A plus B plus C plus C multiplied by A plus B plus C. Now again we multiply A, that is the first term, with each element in the bracket, that is A multiplied with A plus A multiplied B plus C into C. Then B gets multiplied with each term in the bracket. So we get B multiplied with A plus B multiplied with B plus B multiplied with C. And similarly, C gets multiplied with each term in the bracket. That is C multiplied with A plus C multiplied with B plus C multiplied with C. That is, we get A multiplied by A, which is equal to A square, A multiplied by B, which is AB, A multiplied by C, which is AC, plus B multiplied by A, which is BA, plus B multiplied by B, which is B square, plus B multiplied by C, which is BC, plus C multiplied by A, which is CA, plus C multiplied by B, which is CB, and plus C multiplied by C, which is C square. Now we have purple shaded terms, which is A square, B square plus C square. So we have to take these terms together. Similarly, we have AB, BA, which are similar, AC, CA, which are similar, and BC, CB, which are similar. So we get A square plus B square plus C square, and as we know AB is equal to BA, so we write it as 2 times of AB. BC plus CB is equal, so we write 2 times of BC, and AC plus CA are equal, so we write 2 times of AC. So with this we have derived the expansion formula of A plus B plus C the whole square. And now based on this same method we will solve few problems.